Yes, welcome to my dear students. And look here in the previous class, we are discussing about the semiconductors. Especially, you have done the classification of solids on the basis of energy band diagram. You studied in the previous class about the classification of solids on the basis of energy band diagram. As I said in the last class, based on the energy band diagram, we can classify the solids. That is, it may be a conductor, semiconductor, or your insulator. And I said in the last class, what is energy band? Because without knowing energy band, it is not possible to understand the classification of solids on the basis of energy band diagram. And energy band nothing but the splitting of energy levels or group of energy levels. They are discrete and they are closely spaced. This type of grouping of energy levels nothing but energy band. And as I said, if we consider the single atom, isolated atom, there you have an energy level. But if you consider in the solid, as you know, in the solid you are having so many atoms are there. If that so many atoms are very nearer, then what happens? Each electron, they are having the interaction with the neighboring atoms. Because of the interaction of neighboring atoms, the energy level is not same for all the atoms. In that time what happens? The energy will be splitting phase. The energy will be splitting, and because of splitting of energy levels is nothing but energy band. And the energy level splitting, they are very closely spaced and also they are very discrete. This group of energy levels, that is nothing but energy band. And also, I said about, I give more importance to the three important bands. That is about conduction band, valence band, and forward energy gap. And we are discussing in the yesterday's class. Once again, I repeat about what you studied in the last class, and today we go for the types of semiconductor. And today we are going for the lecture number 3. Today we are going for the lecture number 3. So here in the last class we studied about the conduction band, and valence band, and forbidden energy gap. Forbidden energy gap. As I said in the last class, the conduction band nothing but the band because of free electrons. Valence band nothing but band because of valence electrons. And another way, as I said, the energy occupied by the free electrons, that is nothing but conduction band. The energy occupied by the valence electrons, that is nothing but valence band. And forward energy gap nothing but the difference between the conduction band and valence band, or the energy gap between the conduction band or valence band, or separation between the conduction band or valence band, or energy difference between the conduction band and valence band, that is nothing but your forward energy gap, forbidden energy gap. And this also I said in the last class. It means we can classify the conductors, semiconductors, and insulators on the basis of the energy gap or on the basis of energy band diagram. It means you studied in the last class. In conductor what happens? You are not having any gap between the conduction band and valence band. That is, they are overlapping. The energy gap is 0. It means the conduction band and valence band overlap. Because of overlapping of the conduction band, valence band in the conductor, the current will pass through very easily. Why the current pass through very easily in the conductor? Because you are not having any gap between the conduction band and valence band, or they are overlap. The conduction band and valence band are overlapped. Because of overlapping of conduction band, valence band, if you apply small energy or not necessary, the valence electron they can easily move from valence band to conduction band. That's why there are more current in the conductors. What about insulator? As you know, the insulator is a material which do not allow the current pass through. Why the insulator is not passing the current pass through? Because, as we know, we are having the more gap between the conduction band and valence band. We are having the more gap between the conduction band and valence band. That gap is nearly about more than 3 electron volts. That gap is very more. That is about more than 3 electron volts. That's why in the insulator it is not possible to pass the current very easily. And about semiconductor, there is a very small gap between the conduction band and valence band. That gap is about less than 3 electron volts. Because of very small gap, that gap can overcome while applying some small energy in terms of heat or in terms of if you apply any external voltage, we can overcome that gap. It means if you apply some energy, it is possible the electrons they can easily move from the valence band to conduction. That is about the semiconductor. It means in conductor no gap, in insulator so much of gap, but in the semiconductor very small gap. Because of very small gap, you can overcome that gap, or you can compensate that gap while applying some energy. That is about the semiconductor. Now we will go on today's class about types of semiconductors. Types of semiconductor. Types of semiconductor. So here, as I said in the yesterday's class, you have done the two in broad. You can classify the two types of semiconductor. One is called intrinsic semiconductor. One is called intrinsic. Intrinsic semiconductor. And another is called extrinsic semiconductor. And it's called extrinsic semiconductor. Look here, as I said in the yesterday's class, the intrinsic semiconductor is also called as pure semiconductor. If the material is 100% pure, that is nothing but intrinsic semiconductor. The intrinsic semiconductor is also called as pure semiconductor. If the material 100% pure, we call as intrinsic semiconductor. Extrinsic semiconductor nothing but it is called impure semiconductor. It is also called as doped semiconductor. Extrinsic semiconductor is also called as doped semiconductor. It is also called as impure semiconductor. And today we will discuss about the intrinsic semiconductor. Today we will discuss about the intrinsic semiconductor. And look here in the intrinsic semiconductor. Before going for the intrinsic semiconductor, we go some basics. Look here, now we go for what are the important properties. Properties of semiconductor. What are the important properties of semiconductor? The one important thing, it acts as an insulator for low temperature. Low temperature. And second one, it is negative temperature position. Which say semiconductors are negative temperature position. And third one is called, yes, third one is called by adding impurities. adding impurities, adding impurities. Adding impurity, you can change the conductivity. And change the conductivity. It means it acts as insulator for low temperature. It is a negative temperature coefficient, and it is by adding impurities we can increase the or you can decrease the conductivity. And another one is the can write here, that is semiconductors are tetravalent, covalent bonded crystal substance. These are the important properties of semiconductor. One is it acts as an insulator for low temperature. Semiconductor has negative temperature coefficients, and by adding impurities you can change the conductivity. And your semiconductors are called tetravalent covalent bonded crystal structure. And we go for that, what is called covalent bond? What is called the covalent bond? We go for the what is called covalent bond. It is so important to understand about the intrinsic semiconductor. What is called covalent bond? Covalent bond. Here maybe you studied in your chemistry. As I said, the main important property of semiconductor. As we know, the semiconductors are having the tetravalent covalent bonded crystal structure. It means what? The semiconductor having the 4 valence electrons. The semiconductor having the 4 valence electrons. And actually, to make it stable state, to make it the out, we want 8 electrons in the outermost orbit. To go for the stable state, we want the 8 electrons in the outermost orbit. But in semiconductor, there are only 4 valence electrons. How to make it 4 into 8? How to make it 4 into 8? Especially you are studying about the crystal. Crystal nothing but the systematic arrangement of atoms in a solid. It means in solid there are so many atoms are very nearer. And as I said, your semiconductor having the only 4 valence electron, but we want 8. How to make it 8 electrons? It means actually what happens? Your semiconductor, they will take the 1 electron from the neighboring atoms. The semiconductor, they will take 1 electron from the neighboring atoms. It means that sharing of valence electron from the neighboring atoms nothing but covalent bond. Once again repeat. Actually our semiconductors having the 4 valence electrons, but to make it the stable state we want 8 valence electrons. And because of we are having only 4, we want another 4. How to make it another 4? They will take 1 electron from the neighboring atoms. They will take 1 electron from the neighboring atoms. This sharing of valence electron from the neighboring atom nothing but covalent bond. Okay, right here, sharing of valence electrons. From the neighboring atoms, nothing but covalent bond. I will draw the figure, then you can understand very easily about that. Look here, as we know, this is your consider silicon or germanium. Consider the silicon, and it is having the 4 valence electron. As we know, the silicon having the 4 valence electron, and this is the 1 valence electron, this is another valence electron, this is another, this is another. It means, as I said, our silicon or germanium, they are having the 4 valence electron in the outer orbit, but we want 8 electrons to make it stable state. What they will do? They will take from the neighboring atoms. They will take from here having another silicon atom. Here having another silicon atom. Here also another semiconductor, and here also. This also silicon. This also silicon. It means they will take one atom from the neighboring atoms. They will take one atom from the neighboring atoms. It means our silicon having only the 1, 2, 3, 4 valence electron. What it will do to make it stable state? They will take one electron this neighboring, they will take one electron this neighboring, and also will take one electron this neighboring, also will take one electron from this neighboring. This sharing of valence electron from the neighboring atoms, that is nothing but covalent bond. This is nothing but covalent bond. This is nothing but covalent bond. We will ask you the exam. What is covalent bond? The covalent nothing but as usual our silicon or germanium having only 4 valence electron. To make it stable state or to make octet, they will take one electron from the neighboring atoms. What they will do? They will take one electron from the neighboring atoms. This sharing of electrons from neighboring atoms nothing but covalent bond. Sharing of valence electron from the neighboring atoms nothing but covalent bond. That is nothing but covalent bond. I will take this to understand this. I will take one small example. Consider you are writing the exam. It is having the maximum marks. It is having you are writing the paper maths. You are writing the exam, especially maths paper. As you know, in maths paper you are having the maximum marks 100 marks. In that 100 marks, the paper is very tough. And as we know, to pass the exam, how much we want? We want 35 marks. To pass in the subject, we want 35 marks. But you are only getting 31 marks. You solve the paper, but you are getting only 31 marks. And we want another 4 marks. To make it 35, we want another 4 marks. How to take this 4 marks? What we will do? We will ask our friends one question. Then make it 35. This asking the answer for the question, one question from your friends or students, that is the covalent bond. Follow what I am saying. Maximum 100 marks. In the 100 marks, to pass we want 35 marks. But you solve the paper, you are only getting only 31 marks. We want another 4 marks to get 35. What we will do? We will ask the neighboring our friends one answer for that question and we will want 35 marks. This asking the answer for one question from the friends is nothing but covalent bond. Here you are asking the answer for the question. Here you are sharing the one electron from the neighboring atoms. And here we want 35 marks. Here we want 8 electrons. Whereas only 4. But we want another 4. Total we want 8. Your semiconductor having only 4 valence electron. We want another 4. Another 4, how will you take another 4? From the neighboring one electron on the neighboring atoms. That becomes the 8. Here also we want 35, but we have solved only 31. We want another 4. How to make it another 4? We ask our friends from the neighboring students, we ask one question, one problem, then we will get 35 marks. This is the whole very simple way of understanding about the covalent bond. Now we will go for the most important thing, and we have understood what is called covalent bond. The covalent bond nothing but sharing of valence electron from the neighboring atoms. Now we go for the effect of temperature. Effect of temperature on intrinsic semiconductor. Intrinsic semiconductor. Or in some book they are given how the conduction take place in the intrinsic semiconductor, how the current will flow in a intrinsic semiconductor. So here actually, as we know, what is the, I said, the important property of your semiconductor, it acts as the insulator for lower temperature. Why it acts as the insulator for lower temperature? We go for that. Look here, we consider the low temperature and high temperature. Consider the low and high temperature. Consider the low temperature and high temperature. You can understand very easily by drawing the energy band diagram. You can draw the energy band diagram. You can understand very easily about this is your conduction band and this is your valence band. This is the energy. Look here. What happens for the low temperature? If we consider the silicon, that is Eg is nothing but 1.1 electron volt. MCG Eg is nothing but 1.1 electron volt. If considering the silicon, look here. Why in the low temperature your intrinsic semiconductor acts as an insulator? Why in the low temperature your semiconductor or intrinsic semiconductor acts as an insulator? Look here, because you are applying the low temperature. If you are applying low temperature, it means what? You are applying very, very low energy. You are applying the energy in terms of heat. That heat energy not sufficient for the valence electron to move from valence band to conduction band. Or another way, all your valence electrons, they are very tightly bound to the nucleus. All the valence electrons, they are very tightly bound to the nucleus. Or you are applying some heat energy, that energy not sufficient for the valence electron to move from the valence band to conduction band. Or you are applying the energy, that energy not more than 1.1 electron volt. That's why what happens, the valence electron, they are not moving from valence band to conduction band. No doubt you are having the electrons are here. These electrons are not having energy to move from valence band to the conduction band because you are applying very, very low temperature. Because of low temperature, you are applying very small energy in terms of heat. That energy not sufficient for the valence electron, they move from the valence band conduction band. That's why our semiconductor acts as the insulator for lower temperature. Maybe you have followed. It means here what happens, all the valence electrons, they are tightly bound to the nucleus. You are applying the energy, that energy not sufficient to break their covalent bonds, And important thing, especially semiconductor, when you will get the current, if you get the current, first you have to break the covalent bond. Once you are breaking the covalent bond, then only can get the current. Without breaking covalent bond, you are not getting any current. It means to break the covalent bond, we want more energy, especially we want the more temperature. And it means why the insulator, your semiconductor acts as insulator, because you are applying low temperature. Low temperature means you are applying very low energy. That energy is not sufficient to move from valence band to conduction band. That's why for low temperature, your semiconductor acts as an insulator. What about high temperature? What about the high temperature? What about the high temperature? High temperature, what happens? You are applying the energy. You are applying the energy. You are applying the energy like that. You are applying heat energy. You are applying the heat energy. Because you are applying very high temperature, means you are applying very more energy. Because this more energy, what happens? This valence electron, they can easily move from valence band to conduction band. Means you are applying the energy, that is energy more than 1.1 electron. Then what happens? The valence electron that can easily move from the valence band to conduction band. In that time, your semiconductor acts as a conductor. In that time, now here it is insulator. Your semiconductor acts as an insulator. Now it acts as a conductor. Why? For high temperature, your semiconductor acts as a conductor because you are applying very high energy. Because high energy, it is possible for the valence electron, they can move easily from valence band to conduction band. They can easily move from the valence band to conduction band. For what I am saying, it means you are applying the energy. That energy is more than 1.1 electron volt. That's what happens. The valence electron, they can easily move from the valence band to conduction band. In that time, our semiconductor acts as a conductor. Our semiconductor acts as a conductor. This is about the effect of temperature in your intrinsic semiconductor. It is about the intrinsic semiconductor. Actually, if you go in deep in your semiconductor, you have not only the total current I is equal to IE plus IH. It is called electron current plus hole current. And what is hole? What is hole current? In general, especially conductors, the current nothing but electron current. You are only considering the current because of free electrons. But only in semiconductor, the current is not only because of electron, it also because of holes. The total current is equal to sum of the electron current or sum of the hole current. I will maybe ask a question, what is hole? What is hole current? We'll go for that. Look here, if we apply the energy, especially if you consider high temperature, if you apply the energy, if that energy is more than 1.1 electron volt, then what happens? This valence electron, they move from valence band to conduction band. This electron, they move towards the conduction band here. And here, if they move towards from valence band to conduction band, this vacant place of position, nothing but hole. Here, this electron they move towards here. Here you have the vacant place of position. This vacant place of position nothing but hole. And like that, here, this electron having some energy, that also move towards here. Here, this also. It means you are applying the more energy because more energy, what happens? This valence electron, they will break the covalent bond, they move towards the conduction band. Whenever they are breaking the covalent bond, and here this electron, they move towards the conduction band, this vacant place of position, nothing but the hole. The vacant place of position, nothing but the hole. Maybe you are following. You are applying some energy, because its energy, what happens? This valence electron, they will break the covalent bond and move towards the conduction bond. If here they will break the covalent bond, means what? Here this electron, they move towards here. This vacant place of position, nothing but hole. That vacant place of position, nothing but hole. Or this empty place, nothing but hole. The vacant position of the electron or empty place of electron, nothing but hole. The important thing, the hole is having it is positively charged. It is positively charged. As we know, the electron having the negative charge. Because of the property of hole, it is positively charged. What it will do? It attracts the neighboring electrons. It is a property of hole, it attracts the neighboring electrons. It attracts neighboring valence electron. That's what is also called as positive charge. As we know, positive charge attracts the negative charges. It means the hole having the property to attract the neighboring electrons. The hole has the property to attract the neighboring electrons. Maybe you are following what I am saying. It means you are applying the energy. Because of high energy, this valence electron, they will break the covalent bond, they will move towards the conduction band. And if they move towards conduction band, then vacant place of position nothing but hole. And always the hole having the positive charge particle, hole having the positive charge. And this hole having the property to attract the neighboring electrons, Better. This is the hole. According, I am saying according to the energy band diagram, we are explaining about the hole. And actually, here I said, this, they will create one hole here. And otherwise it will not out figure. You can understand very easily. How actually your holes are moving. Look here, here. It is your conduction band. And this is your valence band, and this is very easy. That is about 1.1 electron volt. See your energy. Here what I said here having the valence electrons. For example, you consider this valence electron, because of your applying high energy, they move towards here. You are applying some heat energy. Because of heat energy, you are applying high energy. Because of high energy, this electron, they break the covalent bond, they move towards the conduction band. This electron nothing but free electron. This is nothing but free electron. And here, this vacant place of position, nothing but hole. Because this electron, they move towards the conduction band. This vacant place of position or empty space, nothing but hole. And as I said, hole having the positive charge. And also, important thing, the hole will attract the neighboring valence electrons. And actually, as I said, this hole will attract the neighboring electrons from the valence electron. Then what happens? This valence electron, they move towards here. And here, if the valence electron, they move towards here. Here once again you are creating the hole. And this hole, they will once again attract the neighboring valence electron. Once again you are creating the hole here. And once again this hole, they will attract the neighboring valence electron from the neighboring atom. Here they will create another hole. Once again this hole, they will attract the neighboring valence electron. Here create another hole. Like that. And important thing, you can say this may be A, B, C, D, E. It means what I said, hole current. Now the hole is moving from A to B, B to C, D to E. Okay, right? The movement of hole nothing but moving from A to B, B to C, and D to E. This movement of hole nothing but hole current. Why hole current happens? Because you are applying some energy. Because that energy, the valence electron, they will break the covalent bond, they move towards the conduction bond. This is nothing but free electron. This vacant place of position nothing but hole. And this hole, what they will do? They will attract the neighboring valence electron. If this valence electron, they will be attracted by this hole. Actually, I said here having the valence electron. This valence electron attracted with this hole, and this once again if this becomes vacant place, that becomes hole. And here also, actually it's an electron. This hole they will attract this electron. That it is once again it is a vacant place. That nothing but hole. Like that, you are moving the holes in the valence band. It means what is hole current? The hole current nothing but the moving of the holes in the valence band, nothing but the hole current. And another way to understand about the hole current, you can draw the crystal section. Then you can understand very easily about the crystal section. Look here. it's very small. You understand while drawing the crystal structure how actually your electrons, holes are moving. How actually the holes are moving. Can consider silicon or germanium because both are having the 4 valence electron. It means silicon, same thing can be explained on the basis of crystal structure. Then you can understand very easily about how actually your holes are moving. This is nothing but the covalent bond. As I said already, yes, we can understand very easily about the while drawing the crystal structure. Yes. Here, as I said, it is having the lightweight valence electrons of the this is about the crystal structure of your silicon. Look here, as I said here, this is nothing but your covalent bond. This is nothing but your covalent bond. And as I said here, if you are applying some energy, because of this energy, what happens? Yes, you are applying some heat energy. Because this heat energy, this electron, this valence electron, that is covalent bonded, you are applying some energy. Because this energy, what happens? This electron, they come outside. This electron, they come outside like that. This is nothing but electron. This is they are creating hole here. Because that is said, you are applying some heat energy, you are applying some high temperature, then this you are breaking the covalent bond. You are breaking the covalent bond because of you apply high energy. If you break the covalent bond, what happens? This electron will come outside. And this electron nothing but free electron. It is called free electron. You can write here, it is called your free electron. Free electron. Why it's a free electron? Because you are applying some external energy. Because external energy, you are breaking the covalent bonds. Whenever you break the covalent bond, this electron will come outside. And here you are in a vacant place of position. That vacant place of position nothing but hole. This is nothing but your hole. This is nothing but your hole. Maybe now you are understanding. It means actually it is covalent bonded. And because of you are applying high energy, because at high energy you are breaking the covalent bond. If you break the covalent bond happens, this valence electron, you are applying some energy, they will break the covalent bond, they come outside. You are applying high energy, because high energy, you are breaking this covalent bond, this electron will come outside. That becomes free electron. This vacant place of position nothing but hole. Right. Then this hole, what I said, it is having positively charged. And this hole having the property to attract the neighboring valence electrons. This hole, what they can do? They will attract the neighboring valence electron. Next what happens? This hole will be attracted to this valence electron. It means what happens? This electron will come here, and here having the one another the hole created here. It is maybe your A, this may be your B. And next what happens? This hole, once again they will attract the neighboring valence electron. This hole they will attract the neighboring valence electron. Next what happens? Here you can create another hole. This may be your C. And once again this hole they will attract this neighboring electron, and here you are creating once again the hole. This is nothing but your D. Like that you are moving the hole from A to B, B to C, and C to D. This is nothing but movement of holes. The important thing, the holes are moving in opposite direction to the electron. The holes are moving in the opposite direction to the electron movement. Maybe you forward. It means how actually the holes are moving in the valence band, because you are applying some energy. Because that energy you are breaking the covalent bonds. Once you break the covalent bond, this electron come outside, that become free electron. This vacant place of position nothing but hole. And this hole, what they will do? They will attract the neighboring electron, and this hole they will attract the neighboring atom, and this bond will complete it. But here you have another hole created here. This electron they will attract the another electron here. Now it also completed. But here you are having another hole created here. Like that this process continues. Like that this process continues. Maybe I will give one example. Especially consider your playing Coco. The good example for how the holes are moving. That is something but good example for your playing Coco. The playing Coco is nothing but the moving of holes in the valence band. Or you take another example. In general example you take here, you take one person. It may be your judge person. And here you take another, you can take a student, a judge student, not saying their name. Here another student. It may be A. The student name is A, and this is your student. Their name is B. What actually the A will do? They want some amount. Later, the A student, they want some amount. They want some amount for any sake of purpose. Maybe to fill the college fees. They want some amount. But they are not having that amount. What they will do? They will ask from the judge student. Because judge student is so rich. The judge student is so rich. The A student, they will ask some amount from the judge student. And they will ask some amount. The judge student, they will give them some amount. Later. And now they will fill the fees. Then once again, this judge student, they will ask this. They are given. They will say they will once again they will ask that amount from the judge. But A is not having that amount. What the A will do? He will ask the B to give the amount for judge. They will ask from B. Then the B is given some amount. That amount given back to the judge. But once again, you take this C. They have taken the A student. They have taken the amount from B, and they can give back to the judge. Once again, the B student, they ask the amount to back that amount to A, but A is not having that amount. Once again, they will take from C and give it back to the B. Like that, this process continues. That is nothing but the movement of whole C, B, A, judge. You follow? The judge has so rich student, but the A student, they want some amount from judge. to fulfill the fees. And after filling the fees, they want to give it back to the amount to Z. But A is not having that amount. What they will do? They will take from B to give the amount to Z. And the B is given some amount, they are given back to Z. So once again, the B students have the amount to back. Then what they will do? They will take from C. And once again, they will take some amount from C and give it to the B. And once again, the C will want that back to the amount. Once again, they will take from others. Like that, this process continues. This is nothing but the movement of code. I am saying in general. Maybe it is to understand purpose. But good example, you take the playing of Coco. The playing of Coco is nothing but the movement of force. Will you follow? As I said here, it is from the energy band diagram. We will explain about the movement of force. How actually forces are moving? The forces are moving in the valence band, and free electrons moving in the conduction band. And total current nothing but movement of electrons in the conduction band, movement of holes in the valence band. Total current is equal to the sum of the electric current, sum of the hole current. Maybe you followed. It means the holes are moving in the valence band, and that moving of holes in the valence band nothing but hole current, and moving of electrons in the conduction band nothing but free electron current. Because the conduction band electrons are very free, they can move anywhere. This moving of electrons in the conduction band nothing but the electron current. The moving of the holes in the valence band nothing but hole current. It means the moving of the holes in the valence band nothing but hole current IH, and moving the electrons in the conduction band nothing but electron current. The total current will be IE plus IH. Now you can apply actually if you are not applying any external voltage, then what happens? If you are not applying any external voltage, what happens? The electrons and holes they are moving in the randomly. If you are not applying any external voltage, no doubt, the electrons and holes are moving randomly. If you consider the semiconductor, this is your semiconductor. If we apply the external voltage, then how your holes and electrons are moving? As we know, this is nothing but holes, and this is nothing but your electrons. As we know, the holes will be moved towards the negative side. They are moving like that. The holes are moving towards the negative side, and the electrons moving towards the positive side. The electrons moving like that, and holes are moving like that. As I said, the movement of holes and movement of electrons, they are opposite each other. The movement of holes and movement of electrons, they are opposite each other. If the holes are moving towards the negative of the battery, that is nothing but hole current. Electrons are moving towards the positive battery, that is nothing but electron current. As we know, the electron current and hole current are opposite each other. Like that, your convention current and electron current, they are opposite each other. It means, I am saying here, right? Finally, I is equal to IE plus IH. IE nothing but movement of electrons towards the positive side, that is electron current. Holes are moving towards the positive side, that is nothing but hole current. Movements of holes in the valence band and movement of electrons in conduction band, that is nothing but electron current, that is nothing but the hole current. The total current is equal to the sum of the electron current and sum of the hole current. This is how actually your in the inter-semiconductor electrons and holes are moving. The most important thing, keep it in mind, without breaking the covalent bond, we are not getting the current. And how to break the covalent bond? You have to apply some energy. Because of that energy, you are breaking the covalent bond. And if you are not breaking the covalent bond, you are not getting any current. Another important thing, here, maybe I said here, or maybe I have not said that. Especially another important thing, here you are applying some energy. Because of energy, what happens? This electron, they move towards the conduction band. It means one electron is free. In the same time, one hole is created. The important thing in interest semiconductor, the holes and electrons, they create in pairs, generate in pairs. If you apply some energy, this electron they move towards the conduction band. You are getting one free electron. In the same time, one hole is created. It means the electron and hole they comes in pairs. They generate in pairs. And here also, if you apply another energy, this electron they move towards here. This is become free electron. You are getting another hole. And this electron they move towards here. They will get another hole here. Like that, the important thing in interest semiconductor, whenever the breaking the covalent bond, no doubt, one electron free, at the same time one hole is created. It means you can say the generation of electron hole in pairs. For example, if you are breaking 5 covalent bonds, it means you are having 5 electrons and also you are having 5 holes. That is the importance of your interest semiconductor. It means you are applying some energy. Because that energy, what happens? You are breaking the covalent bonds. Because of breaking covalent bonds, one electron is free. In the same time, one hole is created. It means the electron and hole they are creating pairs. The electron and hole they are creating pairs. This is another important property of your interest semiconductor. Yes, this is about the today's class, and maybe in the tomorrow class we go for the extrinsic semiconductor. Maybe you have followed, and once again you repeat in the tomorrow class in 5-10 minutes. Then you go for another important thing, that is about your extrinsic semiconductor. Thank you.